Most people hear the word transformer and imagine giant robots fighting in a city. Wrong franchise. In AI, a transformer is a type of neural network designed to understand relationships between words, images, sounds, or other pieces of data. It became one of the biggest breakthroughs behind modern tools like ChatGPT. But here's the real question. How can an AI understand which words matter most when a sentence may contain hundreds or even thousands of words? Before transformers, many language models processed text mostly in sequence, one word after another. That created a problem. The longer the sentence became, the harder it was for the model to remember important information from the beginning. It was like reading a whole book but forgetting the first chapter by the time you reached the end. Transformers changed this through a mechanism called attention. Attention helps the model examine different parts of the input and decide which pieces are most relevant to one another. It does not treat every word as equally important. It asks, mathematically, which other words should I focus on to understand this word properly? Take the sentence, "The animal did not cross the road because it was tired." What does it refer to, the animal or the road? A human understands that roads do not usually get tired. A transformer studies the relationships between the words and gives more attention to animal. That helps it understand the context instead of treating every word separately. Think of attention like a meeting. 10 people may be talking, but you focus more on the people whose comments relate directly to the current topic. Transformers do something similar. They connect relevant information across the entire sentence, paragraph, or document. This is why they became so powerful for translation, summarization, question answering, coding, and text generation. Another major advantage is that transformers can process many parts of the input at the same time. Older systems often worked more slowly because they handled language step by step. Transformers made training more efficient on powerful computers, which allowed researchers to build much larger models using much more data. A simple example is translation. Suppose the English sentence says, "She went to the bank to deposit money." The word bank could mean a financial institution or the side of a river. A transformer uses the surrounding words, especially deposit money, to understand the correct meaning before translating it. Context decides the answer. A small case study is Google Translate. Earlier translation systems often produced awkward, word-by-word results because they struggled with long-range context. Transformer-based models improved translation by examining how every important word related to the others. Instead of translating isolated words, the system could better understand the meaning of the full sentence. Transformers were introduced in the 2017 research paper, "Attention is All You Need" by researchers at Google. The title was bold, but the idea worked. That architecture became the foundation for major language models such as GPT, BERT, and many systems used for text, images, audio, and scientific research. But transformers are not magic. They require huge amounts of data, computing power, energy, and careful training. They can understand patterns in context extremely well, but they can still hallucinate, reflect bias, misunderstand reality, or generate convincing nonsense. Attention helps the model connect information. It does not automatically give it truth or common sense. So in one simple line, a transformer is a neural network architecture that uses attention to understand which parts of the input are most important and how they relate to one another. Neural networks help machines learn patterns. Transformers help them understand context at scale. Welcome back to the AI Studio, where we make artificial intelligence simple, visual, and slightly less painful. But if transformers learn from their training data, how can an AI use your private documents, company files, or updated information without being trained again? And what exactly is RAG?